All right, we're going to be going over task card number A. We are factoring out the greatest common factor. So we were rewriting these polynomials in factored form. So for question A, we have the number. We're going to look at the coefficient first, 63 and 45. So if you are not sure what the biggest number is that goes into both of these, but you do know that 3 goes into both of these, or you know a number that goes into them, I'm going to show you a strategy that helps you figure out the greatest common factor. So I'm not sure what the biggest number is that goes into both of these, but I know 3 goes into them. So I would say, okay, 3 goes into 63 21 times. 3 times 21 is 63. 3 goes into 45 15 times. Okay, now I look at 21 and 15 and I say, okay, well, are there any greatest common factors there? Well, I know 3 goes into both of those again. So 3 is the greatest common factor of those two new numbers. 3 times 7 is 21, and 3 times 5 is 15. And then I look at 7 and 5. They are both prime numbers. They have no common factors. So we have found the greatest common factor by looking at these two numbers here. We would multiply them. 3 times 3. Our greatest common factor for this problem is 3 times 3, which is 9. Okay. 9 is the biggest number that goes into 63, but also goes into 45. So you're going to need to rewrite this in factored form. So we would say 9 multiplied with, so 9 is one factor. What do we need to multiply 9 with to make 63? And what do we need to multiply 9 with to make the positive 45m? You can check your answer on Edulastic. And then with question B, the greatest common factor, I always like to look for, does one of the numbers go into the other one? Well, 3 goes into itself. It also goes into 6. So for the greatest common factor, I know that the coefficient that goes into both of these would be 3. And then for the variables, we have 3 n's. So 1, 2, 3. And then we have n to the fifth, 1, 2, 3, 4, 5 in the second term. What I want to know is the greatest number of n's that they have in common. So we've got 1 n in common, 2 n's in common, 3 n's in common. So that is the greatest number that they have in common. So I would say 3n to the third is the greatest common factor. So rewriting this in factored form, 3n to the third is one factor, and we need to multiply that with what to make 6n to the third, and multiply it with what to make a negative 3n to the fifth. With question C, we have 10, 9, and 1. So there's no common factors with the coefficients, but we have n to the third. We have n to the squared in the second term and n in the last term. So I want to know what's the largest number of n's they have in common. Well, they only have 1 in common. So our GCF for this is simply n. That means n needs to multiply with what to give us our original expression. Okay, question D. We have the numbers negative 8, 24, and 12. Now I know my GCF is going to be negative. Anytime our first term is negative, so I'm going to just put over here GCF equals, I know it's going to be a negative. Anytime your first term is negative, your greatest common factor is also going to be negative. Okay. So we always want to factor out a negative in the first term. So I don't know what the greatest common factor is. I'm just going to show you that strategy again if you're not sure. I know that 2 goes into all of these numbers. They're all even. So I could say, okay, 2 goes in, 2 times, I'm going to ignore the negative for now. 2 times 4 is 8. 2 times 12 is 24, and 2 times 6 is 12. Now I look at these numbers again, 4, 12, and 6, and I say, well, 2 goes into them again. And 2 times 2 is 4. 2 times 6 is 12, and 2 times 3 is 6. Now if I look at the number 2, that's prime, no number goes into it besides itself. 3, no number goes into it besides itself, and 6. Well, with all 3 of these numbers, there's nothing else that's in common. So our greatest common factor here would just be the 2 times 2. And remember, we take out a negative because our first term's a negative. So our greatest common factor is 2 times 2 negative. It's going to be a negative 4. For the coefficient, now we can look at the variable part of this. We've got x to the 7th, 1, 2, 3, 4, 5, 6, 7. We've got x to the 6th, and we've got x to the 5th. Now, in terms of what they have in common, they've got 1, 2, 3, 4, 5 x's in common. So our greatest common factor would be negative 4x to the 5th. So that means you're going to rewrite this out as a negative 4x to the 5th needs to multiply with what 3 terms to get our original expression? Question E. We've got a 3, 9, and 27. Well, I know 3 goes into itself. I know it goes into 9, and it also goes into 27. So for our greatest common factor, it would just be a 3. And in terms of variables, we have 2 m's, we have 1 m, and we have no m's. So there are no m's that they have in common. So their greatest common factor is simply 3. And we would need to then rewrite this out as 3 multiplied with what to get our original expression. Okay. And then our very last term here, we've got question F. Let me get myself some more space for that and put it here. All right, so I'm going to use that strategy I used earlier with this. We have 64, we've got 40, and we've got 72. Now, I don't know what the greatest common factor is between these numbers, but what I do know is that 2 goes into each of these. So I'm going to put a 2 here. Now, 64 divided by 2 is 32. 40 divided by 2 is 20. 72 divided by 2 is 36. Now I look at 32, 20, 36. Okay, I don't know what the greatest common factor is between those, but I do know 2 goes into all of them again. So 2 times 16 is 32. 2 times 10 is 20. And 2 times 18 is 36. Now again, I know 2 goes into all of these numbers again, and I get an 8, I get a 5, and I get a 9. All right, now we've got 8, 5, and 9. In terms of all 3 of those numbers, there is no number that goes into all 3 of them. No more common factors. So then I would say, okay, I've got a 2, a 2, and a 2. So if I'm looking for my GCF of 64, 40, and 72, it would be 2 times 2, which is 4, times 2, which is 8. The greatest common factor that goes in all 3 of those is 8. And then we've got no variables, 2, and then 1. So it would just be an 8. So 8 multiplied with your 3 terms to get the original expression.